So in today's video, I'm going to walk you guys through a trig question because you guys weren't really tested on that in paper 1, meaning that it will most likely come up in paper 2. So if we get started with part A, you can see that it's an addition formula question, right? Because it's one angle subtracting another angle inside your trig bracket, right? So what's the addition formula for sine? Sine of A minus B is equal to sine A cos B minus sine B cos A, right? Cos of A minus B is equal to cos A cos B plus sine A sine B. Both of these are given in your formula sheet. So now if we apply these to the question, on the left hand side we have two lots of the sine formula, right? So sine of A, so sine of x, cos of B, which is 60, minus sine B, so sine of 60, cos of x is equal to the right hand side now. So we have cos x and cos 30, right? So cos of x, cos 30 plus sine of x and sine of 30. Okay, now if we plug in the trig values, we're left with what? Two lots of sine of x, but that's multiplied by cos 60, which is just a half, minus sine 60, which is 3 over 2, root 3 over 2, cos x, and that's all equal to cos of x, cos 30. The value of cos 30 is also root 3 over 2, so I'm going to write that at the front. That's cos x plus sine of x, sine 30. Sine 30 is just a half, so we're just left with a half of sine of x, right? Now, if I expand the bracket on our left-hand side, we're going to cancel out the denominators being 2, right? So it's going to be, we're going to be left with sine of x minus root 3 cos of x. That's all equal to root 3 cos of x, or root 3 over 2 cos of x plus a half sine of x. Now the best thing to do is bring the sine terms to one side and bring the cos terms to the other side. So I'm going to take the sine terms to the left hand side. So sine of x minus a half of sine of x is all equal to root 3 over 2 cos of x plus root 3, there's no over here, so it's just going to be root 3 cos of x, right? Now if we collect the like terms, we're left with a half of sine of x is equal to 3 root 3 over 2 cos of x, and if we times out the denominator being 2, they cancel out each other, so we're just left with sine of x equals 3 root 3 cos of x, right? Now take the cos to the other side. We're left with sine x over cos x is equal to 3 root 3. Sine x over cos x, that's just equal to tan x from our identity. So tan of x is equal to 3 root 3. And that's what we wanted from the question. Now part B wants us to solve for 2 sine 2 theta is equal to cos 2 theta plus 30. So let's write that out. So, So 2 sine 2 theta equals cos 2 theta plus 30. And I'm going to write that in a bracket. Now in this case, we're just going to be, x is going to equal to 2 theta plus 60. Why? Because the sine 2 theta is what we want, right? So if we look at our original question, our original equation, if we have 2 theta here, that's what we want alone. The plus 60 with the x gets rid of this minus 60. So we're left with 2 theta overall if we plug it in. So tan of 2 theta plus 60, we're looking at our proof now. So we just plug this in because this is the same as this. If we plug in x equals 2 theta plus 60 is all equal to 3 root 3, right? So now what can I do? I can say arctan of 3 root 3. So 2 theta plus 60 is equal to the arctan of 3 root 3, which is what? 79.1 degrees, right? Now I can use the cos diagram and just add 180 to it because we're looking at tan. So the other value would be 259.1, right? That would be our last value because our interval would be only up to 360 because we times theta by 2. Now all we have to do left is rearrange for theta. So 2 theta will be equal to, what's it, 19.1 degrees and 199.1 degrees. So theta is equal to 9.6 degrees and 99.6 degrees, and that's it.